Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from our curious viewer, Bubble Fan Kendra. Thanks for the suggestion, Kendra. You asked, how do soap bubbles actually form? If you've ever blown a bubble and watched it shimmer and float away, you've probably wondered, what's holding this fragile little miracle together? Well, today we're diving into the bubbly blend of physics, chemistry, and a touch of magic that makes soap bubbles possible. So, whether you're a bubble enthusiast or just here to satisfy your curiosity, stick around as we unravel the science behind those rainbow-filled spheres, right here on Explaining Everything. To understand bubbles, we first need to meet their creators: water, soap, and a little air. Water is the starting point, but it has a problem. It's a bit too clingy. Water molecules love sticking to each other because of something called surface tension. Think of it like a group of introverts at a party. They're all huddled together, unwilling to branch out. This is why plain water doesn't make bubbles. Enter soap, the social butterfly that breaks up the clique. Soap molecules have two sides. One loves water, and the other hates it. The result? Soap reduces water's surface tension, making it more flexible and willing to mingle. Voila! The stage is set for bubble formation. When you blow air through a soap-water mixture, you're essentially inflating a tiny balloon. But this isn't any ordinary balloon. It's a thin film of soapy water stretched between two layers of soap molecules. Picture a sandwich where the bread slices are soap molecules and the filling is water. This structure is known as a soap film. The soap molecules stabilize the film, keeping it from popping immediately. Without them, the water would collapse under its own surface tension faster than you could say, bubble trouble. Bubbles aren't just pretty, they're also perfectionists. They form spheres because a sphere is the shape with the least surface area for a given volume. It's like bubbles are saying, I'll float, but only if I can do it efficiently. This spherical shape minimizes the energy required to maintain the bubble. Sure, you can get funky shapes when bubbles are trapped or stuck together, but left to their own devices, they'll always aim for that perfect, energy-efficient orb. Now, let's talk about those mesmerizing rainbow colors. Soap bubbles act like tiny prisms, bending and reflecting light. When light hits the thin soap film, some of it bounces off the outer surface, while the rest passes through and reflects off the inner surface. These reflected rays interfere with each other, creating what's called iridescence. The thickness of the soap film determines which colors appear. So, as the bubble wobbles and stretches, it's basically putting on a light show. Mother Nature's very own laser party. Bubbles might look carefree, but they live precarious lives. Gravity pulls the water down to the bottom of the bubble, making the top thinner and more likely to pop. On top of that, evaporation is constantly stealing water from the bubble's film. This is where glycerin or sugar comes to the rescue. These bubble-friendly additives slow down evaporation, giving your bubbles a fighting chance to last longer. They're like the personal trainers of the bubble world, helping them stay strong and float proudly. Despite their charm, bubbles are fragile creatures. A bubble pops when its soapy film becomes too thin to hold together. This could happen because of gravity, evaporation, or even an unfortunate encounter with a sharp object or your curious finger. Fun fact, bubbles also pop when they encounter grease or dirt. That's why you'll never see a bubble thriving on an oily frying pan. Clean surfaces, happy bubbles. Soap bubbles aren't just for fun. They've got some serious street cred in science and engineering. Bubbles are used to study fluid dynamics, measure airflow, and even clean delicate objects. And let's not forget the bubble baths. Sure, they're relaxing, but the bubbles also serve a practical purpose. They help insulate the water, keeping it warmer for longer. Who knew your bathtub could double as a physics experiment? Blowing bubbles is one of those simple pleasures that transcends age. It's a universal language of joy, spoken with a wand and a gentle puff of air. Whether you're 5 or 50, there's something magical about creating a floating orb of color and watching it drift into the sky. Just remember, every bubble is a tiny miracle of science, art, and a little soap. So, the next time you see a bubble, take a moment to appreciate its complexity. Behind its delicate appearance lies a story of molecules, light, and physics, all working together in harmony. Who knew a little soap and water could create so much wonder? And if you didn't know before, now you're ready to blow some minds, literally and figuratively, with your newfound bubble expertise. If you enjoyed learning about the fascinating formation of bubbles, don't forget to give this video a thumbs up. Hit that subscribe button and turn on notifications so you never miss an episode. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.